Hi everyone, welcome back to Mechatronics lab. Today we will discuss about the experiment number 1 in part A, that is design and simulation of basic logic gates. This covers objective of this experiment and introduction about digital logic gates and its types and its symbols, truth table and Boolean expression. Then we will see the procedure to simulate the logic gates using simulator. Then we will see the simulation of these logic circuit using simulator software. Then we will discuss about the result with some practical application. First we will see what is the objective of this experiment. The objective is to design, simulate and verify the truth table for the following logic gates using digital circuit simulator. The digital circuit used here it is Logisim 2.7.1. Next we will see what is logic gates. Logic gates are the basic building blocks of any digital system. The digital system is a integral part of all electronic devices. Nowadays our life is full of electronic devices only. These digital circuits is built by using logic gates. These logic gates will operate with one or more inputs and it will give only one output of digital type. The inputs operates on the digital signals only, that is binary numbers, that is 0 and 1. These logic gates can be classified as basic logic gates, universal logic gates and other logic gates. These universal logic gates and other logic gates are grouped together as derived logic gates. These derived logic gates are constructed using basic logic gates only. The basic logic gates are AND, NOT and OR gate. The universal logic gates are NAND and NOR. Other logic gates are exclusive OR and exclusive NOR gate. We will see what is AND gate, NOT gate, OR gate with one by one with its function and its truth table, Boolean expression and its symbol. First we will see AND gate. Before going to AND gate, we will see what is truth table. Truth table is a table which gives possibilities of output and inputs for a given logic gate. For example, if we have two inputs for a gate, there are 4 possibilities of output for a 2 input set, because 2 to the power of n is the input, means 2 inputs means 2 to the power of 2 is equal to 4 outputs. It will give the what are the outputs for a given set possibilities of input, and the Boolean expression will give the relationship between input and output of the logic gates with appropriate symbols. First we will see what is AND gate. AND gate is a gate which is used to perform logical multiplication operation, and generally we are called it as AND function, and it is similar to multiplication in arithmetic. And here the output of AND gate is 1, that means I, when both the outputs are 1 1 means I, otherwise the output is 0. We'll see what is the symbol used to represent AND gate. The symbol is, this one is the symbol used to represent A and B are the inputs, Q is the output. Here the Boolean expression is used to represent AND gate is Q is equal to A dot B. This dot is used to represent AND function, or sometime we can write directly AB, that also okay. See here, when input A is 1, B is 1, then only output Q is 1. If any one of the input either A or B is 0, then Q becomes 0. We will see in the truth table. See here, when both the inputs are I, then output is I, otherwise the output is low. You see here 0 0 is there, 0, 0 1 is there, 0, 1 0 is there, 0. If both the inputs are 1 or I, then only output is 1 or I. You'll see this in animation. See here, green represents I or 1, red represents 0 or low. See, The output turns into green when both the inputs are in green only. Otherwise, the output becomes red only. You observe carefully here for different combination. See here. See. See here. This is AND gate. Next we will see OR gate. The OR gate is used to represent the logical addition operation, and generally we are called it as OR function. It is similar to addition in arithmetic. Here the output of OR gate is I when any one of the input is I, and the output is low when both the inputs are low. See, if you want output is I, if any one of the input is I is enough. If you want low, then both the inputs are low. The symbol used to represent the OR gate is this one. A is the input, B is the input, Q is the output. Here, if A is 1, B is 0, the output is 1. If both 1, then the output is 1 only. If both are 0, then the output becomes 0. The equation used to represent this OR gate is Q is equal to A plus B. This plus symbol is used to represent OR function. We'll see the truth table. See here, if both the inputs are low, then output is low. If any one of the inputs are I, then output is I. We'll see in the animation. See here, the output turns into green when any one of the input is green. If both the inputs are red, the output is red. See here. See. See now both the inputs are red, that's why red. See, this is OR gate. Next we will see NOT gate. What is NOT gate? NOT gate is a inverted gate. We are called it as inverter or complementary gate. We are called it as, because here it is having only one input and only one output. It will give an output is inversion of its input. If we give 1 as an input, it will give an 0 as an output. If we give 0, it will give 1. That is NOT gate. That's why we are called it as a inverter gate. See what is the symbol used to represent NOT gate. The symbol used is this one. If A is 1, Q will be 0. If A is 0, Q will be 1. See, this is the equation is used to represent is Q is equal to inversion of its input. See, this bar represents in Boolean is complement. The truth table is A is equal to A bar, output is A bar. If you give 0 as an input, it will give 1 as an output. If you give 1, it will give 0. You can ask, in previous 2 inputs are there, 4 combination, here it is 2. Already I told it is 2 to the power of n combination. That is, n is the number of inputs. Here it is only one input, that's why 2 to the power of 1, 2 combinations. See, this NAND gate is also known as inverter, as it inverts its input or complements its input. We are called. We'll see the animation here. If you see here, if you give red as an input, it will give green. Green is input, red is an output. This is then NOT gate. See, this is NOT gate. These 3 are the basic logic gates. Using these 3, we are constructed the NAND and NOR. These NAND and NOR gates are called it as a universal logic gates. Why we are called it as universal logic gates means, if you want any basic gates means we can construct using these NAND and NOR gate. That's why we are called it as a NAND. If you want AND operation, we can get by using NAND and NOR. If you want OR, if you want NOT, we can perform using NAND and NOR gate. NAND gate, it is equal to the AND gate followed by NOT gate. The output of the NAND gate is inversion of the output of the AND gate. Here the output is low when all the inputs are I, The symbol of the NAND gate is the AND gate followed by a circle on its output. If A is 1, B is 1, then output is 0. The Boolean equation for this NAND gate is Q is equal to A into B. You just observe here, if AND gate is A into B, just inversion of this AND gate is the NAND gate. The truth table is as follows. This, if both the inputs are I, the output is 0. If 0 0 as an input, the output is I. 0 1 is also I, 1 is also 1 0 is also I. This is an NAND gate. You will see in the animation. See here, the output turns into green when all the inputs or any one inputs are low. If all the inputs are I, then output turns into red. You observe. If both the inputs are green, then output is red. You observe. Okay. This is a NAND gate. Next we will see NOR gate. This NOR gate is equal to the OR gate followed by a NOT gate. Here the output is inversion of OR gate output. We will see the symbol for NOR gate. The OR gate followed by a circle at its output. Here also the equation is used to represent the NOR gate is Q is equal to A plus B whole bar. Bar represent complement. We know A plus B is representing OR gate, just followed by NOT gate means NOR gate. The truth table is, observe, if 0 0 1, 0 1 means 0, 1 0 means 0, 1 1 means 0, just opposite to the OR gate. In OR gate, except first 0 0, here it is 0, remaining are 1. Here it is just reverse of that one. You will see in the animation. You see here, when both are 0, then only output is I. This is OR gate. Just inversion of this. You observe here in truth table. See here, just reverse. If 0 0 means 1 in NOR gate, in 0 0 means 0 in OR gate. See, like this you compare. This is OR gate simulation. This is NOR gate truth table. Next we will see XOR gate. This XOR gate is constructed by using NAND and NOT gate and NOR gate. Here the output is I when the inputs are different. If the inputs are same, the output is low. The symbol for the XOR gate is this one, OR gate, with one curve behind this one and this. Thus, equation is represented using Q is equal to A XOR B. This plus insert within the circle plus symbol. This is a XOR symbol. This is A plus A XOR. We are called it as XOR B is equal to A bar B plus AB bar. This is the full equation. A bar B plus AB bar. We'll see the truth table. See here, 0 0 0. You observe here, if both the inputs are same, the output is low. If inputs are different, the output is high. This is the XOR gate. Next we will see the procedure to simulate the logic gates using Logisim 2.7.1. First step is to open the Logisim 2.7 and start a new file by clicking File New. In the menu bar, file is there. Under that you click on New, it will open a new file. This is the first step. Next we have to construct the circuit by using, first you have to place the logic gates. Select suitable gate in the library and place it on canvas, that is working window. Then select number of inputs required for gate in attribute panel. By default it is coming with 5 inputs. We have to select number of inputs required as per our lab requirement in attribute panel. Then after placing the logic gates, you have to place the input component. Place the input component by clicking on this icon in the toolbar. With a square box, there will be a green icon, or by pressing a Ctrl 4 also we can place. Next, once placing input component, we require output component. That also you can place the output component by using Ctrl 5 or by pressing the circular green icon which is present in the toolbar. After placing these three gate, input and output component, you have to wire them by dragging the connection. Next step is to connect the output of the gate to the output component and input of the gate to the gate component. Next, run the simulation by clicking on AND tool. There will be AND tool. We record it as a poke tool in the toolbar. By clicking on, we can change the input combination of the gate and record the outputs by changing the state of the input at input components. For that, we have to choose the poke tool which is available on a toolbar, that is the AND symbol. Next, tabulate the output in the truth table. We know what is the truth table. We have to tabulate and verify them. This is the procedure to simulate the logic gates in a digital simulator. Next, we will see the how to simulate. I will demo for each gate how to simulate using the Logisim 2.7.1. First, open the simulator which is installed on PC by double clicking. It will open. I already told this is the canvas window, this is the library, this is the attribute pane, this is the toolbar, this is the menu bar. First I will show one by one. First I will show AND gate. For AND gate, I will place an AND gate by selecting under the gate folder. AND gate, I will place it here and I will change the number of inputs as 2. Then I will increase the size in gate size to wide. Then next I will place a input component by clicking on a circular green icon. 2 inputs are required. Then I will place a output component by circular pin by clicking on that. Then I will wire by dragging. Then I will label the input and output components. This is a input A, okay. Then select this save and copy and paste it remaining labels and then edit. I will rename it as a B because I was pasted from previous one. This is Q is equal to A dot B because it is an AND gate. This is AND gate. I will label it as an AND gate. AND gate. The labeling is over. Well, next I will simulate it. First I will take a click on a poke tool. Then I will see by default 0 0 it is there. In AND gate, when both the inputs are 0 0, the output is 0 only. Next, if the inputs are 0 1, if A is 0, B is 1, the output is 0 only. If A is 1, B is 0, then output is 0. If both the inputs are 1 1, then output is 1. This is the AND gate simulation. This can be see the truth table for this AND gate in under project analyze circuits. See here the truth table for this and get 0 0 0 0 0 1. This is the truth table, and these are the inputs, and this is the output. This is the expression, Boolean expression, A into B. See, this is the AND gate simulation. After simulated, you save this one in your local path wherever you required. See, I will save under, I will create one folder in desktop for demonstration purpose. See, this is experiment number 1. Under this you give it as AND gate. Save. See, the first gate is over. Next I will show. Next again I will go to File, New, Show. I will perform a simulation of OR gate. Again same OR gate. Click on this one. Edit for number of inputs as 2 and increase the size as wide. Then insert a input component. Then insert a output components. Then connect. And label it. Okay, select it and paste it wherever you required for remaining places. Then edit. This is OR gate. This is B. This is output Q is equal to A plus B. Then simulate by clicking on poke tool. That is 0 0 0 1 0 1 0 1 1 1 1 0. This is the OR gate. After completing the simulation, just save it the path. OR gate. Save. Next I will perform NOT gate. Place here. Here it is only one input, that's why it will coming with one only. Wide, already it is wide. Just one input, one output. Connect this. Label it A. Q is equal to A bar. Here output is Q is equal to A bar. I will increase the size. Okay. Okay. See here. We'll simulate now. If you give 1 as an input, it will give 0 as an output. If you give 0 as an input, it will give 1 as an output. Just what input we are giving, just opposite output it will give. This is a NOT gate. Same way, you can save this also as a NOT gate. Next I will show NAND gate. That is under gate, go for NOT gate, NAND gate, place it here, change the number of inputs as 2, then make it as wide then place a input component and output components, then wire them, then label it as EA, change the size and color and font, then select and paste it at different places for different parts labeling. See here, I will change it as a B. Here it is Q is equal to, open the bracket, A into B, close the bracket, whole bar. This is NAND gate. Type it as a NAND gate. Then simulate. See, here it is when it is just opposite to the AND gate. In AND gate, when both the inputs are high, it will give I. You will see here it will give it 0. In AND gate, if any one of the input is low, it will give low as an output, but here it will give a high. You will see. See, this is a NAND gate. Save it. NAND gate. Next, we'll show you NOR gate. Before that, I will show you NAND gate also constructed using AND gate and OR gate. We'll see. Sorry, I will open. I will previously stored one, that is file, open, NAND gate, open. This is a one directly symbol available, or we can construct by using and NAND gate. C, AND gate, then NAND gate, place it at its output and place it to inputs, connect, then connect, then connect the output component. Copy, paste this label, same label. See, this is the NAND gate, equivalent circuit for NAND gate. We'll see, one is 0. Here also if you click, one is 0. If you give 0 0, it is 1. Here also it should give 1. This is the equivalent circuit. You save both, save just. Next, I will show you OR gate. Sorry, NOR gate. Place it here, edit to inputs, place to inputs, place output component, then wire them and name them A, size 20, board, mate. Go to select, then select, copy, paste for remaining places, and then edit. Edit it as a B. It is Q is equal to, open the bracket, A plus B, close the bracket, code, that is inversion. This is name it as a NAR gate. In the same way, you can construct equivalent circuit using NAR, OR and NOT gate. The both outputs are same. See here, simulate. 1 1 is 0. In OR gate, 1 1 means output is 1, but here it is opposite. See, 0 0 means 1, 0 1 means 0, and see just the outputs are opposite to the OR gate. In this way, you can simulate the gates. Next, I will show final one, that is XOR gate. Save this one before that as an OR gate. Save. Next file, new. Go for gates, insert XOR gate. See, edit the number of inputs as 2 and make it as a wide size, place the input component and place the output components and wire them. Connect, then label A, edit board 20, OK, then go to select toolbar, then copy paste, and edit the label. It is B, this is Q is equal to equation is A bar into B plus A into B bar, and you edit this one as a XOR gate. Now simulate. XOR gate means when both the inputs are similar, the output is low. If both the inputs are dissimilar, then output is high. We'll check it. See, if both the inputs are 0 0, then output is 0. If both the inputs are different, here it is 1, here it is 0, the output is 1. Check for other combination also. 1 for 1 1 0. This is XOR gate. Save it. XOR gate. Save. You can verify the truth table by going project, analyze circuit, and OK. This here. And both the inputs are dissimilar, the output is 1. If both the inputs are same, the output is 0. The expression is this one. See, this symbol is inversion. See, you can check like this for all gates and for all experiments. You practice, you will get an idea. It is very simple. If you go through and you will get an idea. Next, we will see result. We simulated everything and we check the truth tables. The result is all basic logic gates are designed. We built it and simulated using Logisim 2.7.1 circuit simulator. Also, we have tabulated the truth table. We checked the truth table also. All is fine, well, correct. This is the result. Before ending this class, we will discuss about some practical applications of these logic gates. Here I am showing one example. You are observing. Here we are using AND gate. It has two inputs, means these two inputs are connected to two switches. One is micro switch, another one is switch. The output is connected to the machine component. This machine component has to on when both the switches has to be on. Then only the machine will be on. If any one of the switch is off, the machine will not be on. It is in off condition. You observe. When both is on, then only it will on. If any one of the switch is off, this will be off. This is the one practical application. In many automatic machines they will use for controlling and all. You see in washing machine or any other devices they will use this one. This is the one application. You observe here, if both the switches are on, then only it will on, otherwise it will off. This is the one example. One more example is to washing machine. When the motor is to be turned on, when it has to be turned on? When door has to be closed, water level is correct, water temperature is correct, then only motor will be on. You observe here, when all these three inputs are turned into green, then only motor is also color also green, otherwise it will remains red only. You observe, see here, when the motor is turning on, the right temperature, right water level and closure of the door is correct, otherwise the motor is switched off. You see everything, see here. This is the one application. Here they use NOT gate, AND gate, everything. Not only you can use this gate, you can use many other gates also in different application. This is the one application. One more application is to this one. This is the calculator display. In calculator display you observe, this is the number on. You can, here hide market is there. See here, this is 7 segment display where card. You will study in theory in detail in the theory subject. See here, this is the one more application of this. These are all gates they are using here. These are all some practical application. Not only these three I will show, just 3. You can use many more. Okay. Thank you.